Hello, let's have a look at what's the meaning of circularity. We are interested in providing different tools for developing the sustainability within the built environment. We have had a look at materials, at architecture, at the different elements. Now, after measuring the impact, it's time to make an analysis of other approaches that can contribute to the final objective. I am Javier Orozco from the Department of Materials and Mechanical Engineering at UPV. First, let me introduce the Ellen MacArthur Foundation design on circular economy. There are two sides of circularity. First, the different activities related to the movement of materials, the technical cycles, and then the biological cycles, which are related also to energy. From the point of view of the process, we start with raw materials as with energy. For these raw materials, we can take new materials coming from nature, from the normal first use processes, or we can take parts which have been used before but are still adequate for their direct introduction, that's reuse. We can recycle different elements of previous developments of previous machinery into their raw materials for introduction and creation of new parts, and so on with all the different technical cycles. Regarding energy, it's the same. We can take energy from normal processes and from other which are connected to the reuse and recycling of elements. After that, we go to the product manufacturer, the service provider, and the final user, which can by himself relate to internally the technical circles and feedback onto all that. In the end, those materials, those elements which have no further possibility of upgrading or recycled are used for energy recovery in some cases, and finally for landfill. So in that sense, what we are doing is by the action of people, of men, we are reusing materials and we are taking a load off the burden to nature, and that's the most important thing for our impact assessment on sustainability. What are the key elements that we can consider and should we concentrate on the circularity? First, obviously, energy recovery, water factory, water reuse, education and R&D for not duplicating elements. There are biomanufacturing, design, digitization, community. All of them are the different traits, the different technical cycles which should be analyzed. Let's go a little bit more in detail. What are the main priorities in order to develop the activity towards circularity or cyclic economy? First, think in systems. What do we mean by thinking in systems or think about systems? We have to think not from our own personal point of view, but understanding what's the whole cycle for whatever we are doing, we are producing, and how we are taking materials and having an output. All this is very important in order to concentrate on how to take alternative sources for raw materials, or how to use what has been left out after our work, not as waste, but as an input to other circles. And also important are the vicinity loops. All this is especially relevant when we are thinking of a very close approach, a very close environment where our measures can be much more effective. In that sense, the close neighborhood supply is related to this system thinking within vicinity loop. So the social activation of people for trying to change their priorities onto how they take their products, their income, and how they use their waste is important. So the output of the close neighborhood supply is waste reduction and the reuse of materials and elements. So those are the basic elements which should be included from the social and industrial activity within cities for a better circularity. The built environment. Let's see what are the objectives that can be obtained by this approach. First, a possible impact on circular economy on 3% of CO2 emissions. This is a lot. So simply by not buying brand new raw materials for our new buildings, we can save up to 3% in CO2 emissions. Why? Because materials have a high impact. The building certification also, after the building is finished and after it's commissioned and is in use, can save energy for air conditioning, for a number of things, including illumination, that can help in saving also. The material certification also makes it compulsory for companies to look for alternative supplies, which normally would be disconsidered because they are more risky or more expensive, but depending on the certification and the cost of using these materials, the things are changing. So all in all, we will leave 17% less of waste that doesn't go to the dying cycle processes and save 3% in carbon footprint emissions. So this is a lot that can be gained by including the circularity in the process of developing new buildings. Regarding the key performance indicators regarding to the built environment. The percentage reduction in raw materials consumption over GDP is a perfect measurement on seeing how we rate one to each other at city level, at country level, or at world level. The same with the percentage of reduction of tons waste. Our objective, as we said, was 17%, the same as the reduction in raw material, which is leading to this 3% saving carbon footprints. The percentage tons of secondary origin means reusing material or recycling materials or the overall materials used in the building. The same of the reused, so first is recycled, second is reused, and the global percent of circular materials in use. So as you can see, we are measuring the income of materials and how they are distributing in the different processes, and the waste which is generated, which will produce the impact that we sent. Regarding the action points, the specific activities where we can address our work is the grey water capture and management for the building. So all this is related to things we have introduced in the building that help into the operation of the building. Those are then the action points regarding the new building development, the new built environment paradigm. Grey water capture and management. If we are able to separate grey water, those waters coming from showers, from baths, which are not so dirty, they are not completely polluted, they have a different cycle to the really dirty waters, the black water, but they are reused for gardening, they are reused for urban growth of vegetables and so on. So this is very, very important. Second, if we introduce a lot of refurbishment in the existing building stock, we can save a lot of energy. And the policy is devoted to that, to better isolation, new windows, and all in all, reducing the energy lost in the building during its operation. That can help also a lot in the overall figure. For new buildings, introducing bioclimatic standards is important. Why is important bioclimatic standards? First, because we don't need to produce artificially the heat or the cold. Second, because then we are not depending on the electricity, but we are using the natural current, the natural elements to provide a better atmosphere in the building, which is best for the health of people. Also important is the introduction of green infrastructure, which will help in cleaning the atmosphere, saving the temperature rising on the heat islands, and also providing a better feeling for the people because of the green and the biodiversity, as well as a minimum consumption if we are able to introduce these elements properly and watering them with the grey waters. Regarding tax policies on housing and supplies, the same as social network activity, is a great help into making these new activities proactive and saving the gap of the additional cost which is required by these measures into a better social perception or even saving of taxes. Regarding each of the phases of the building development, on the design of the building, depending on how we are using on our design modules or modularity, how we are specifying technically the materials, how we are assembling them for later deconstruction, or making it easy to change the overall layouts for different uses, we are saving a lot of raw materials and therefore carbon footprint. Regarding the manufacture of supply, if we go into the eco-design, it will mean that we're introducing the bioclimatic rules, the energy required on the buildings will be less, and so they will be more energy efficient. We will avoid critical materials which are either very bad for your health or critical from the provider point of view, which will also be better for future development of alternatives. It will provide a long lifespan if we select adequate the materials for durability. The disassembly and the reverse logistics of the whole buildings there are enhanced with all these possible alternative manufacturers and supply elements. In the construction phase, we have to avoid waste, obviously. We have to go more into the prefabricated prefabricated elements assembled in place and less into the detailed activities or parts done during the works. The recycle and reuse of raw materials is obvious on this phase. Once we are working with our own spaces on the buildings that have been developed, we should also be avoiding waste. We should be very careful on the processes we are installing, the installations, in order to have easy maintenance, make good use of the original adaptability and making things more flexible, so that the overall maintenance on repair and upgrade is less costly. And once the building finally has been discontinued its use, we should be able to deconstruct the different modular elements that have been assembled for loop, recycle, and reuse. So all these activities will help into our objectives of circularity. So here we are presenting specific activities from disassembly. Let's start from the previous one to the resource facility, recovered material, the factory, the assembly, and the use. So from the point of view the user, we are going to a cycle which is specifying the design for service, the design for flexibility, the design for the long life use, design for ease of use, and for the construction. Each of these circles is connected. For example, the deconstruction is connected to the disassembly, resource facility, recovered material, and impacting the factory and later assembly. So all the processes that we introduced before are actually being proactive into the development, and we see how they are nested together for a more important impact on the overall result. The supply chain is where we should address our focus. First, because they have a bigger share on emissions. Second, because company can control better than anybody else the impact of all these things. So how can we convince the supply chain? It's very simple. If people are looking for a specific type of recycled or sustainability standard certification on the products, the supply chain will provide them because they will be earning a bigger market approach. Second, the additional costs have to be compensated through tax elimination. And in the end, the energy saving, the less waste, all the management costs which are related to a bad use of materials can be returned by the government to the supply chains for a wider use of these facilities. So we should concentrate all our governmental policies in facilitating the attractive of these elements to the supply chains, and also reinforcing the market through the social atmosphere regarding these elements. Well, we have shown how things can be done circularly, and although we are not pinpointing specifically one element, if we provide an attitude which is described here, the overall impact that we have been able to measure before will be very wide, and our cities will be more sustainable. Please have a look at the video on this link, which is a very good approach on seeing the new technologies that will become popular in the near future and that are strictly and very intimately connected with these technologies. Thank you very much, and remember all these elements regarding the reuse of the materials on this video. Bye for now.